Yes, we are live. Uh, Eric, my rover is on that ngrok URL. But when I go to yakrover.com and then select rover A, it doesn't forward the uh, request to my rover.
Mhm. So I look into it right now, but it seems the URL has changed, right?
Yeah, so every time you start, I think it gives you a new URL unless you are on the paid account.
So if the URL to the rover changes, basically the mini app, there is no discovery system, so we have to update the mini app as
So I
well.
updated it actually in the morning.
Okay, so just I'm double checking. Huh? Um, all right, the port is correct. The rover is listening to port 80.
Mm, yeah.
Okay.
So I added two variables to the environment. Uh, One is the rover A base URL and rover B
Yeah, thank you.
base URL.
I see. So the work I've done this week is going to change all that. Okay, so
Okay.
but looking at what you've done should work. Okay, so sorry for everyone listening. It's just that we have a configuration file, and so far it was very simple. It was for each rover we have to define the URL. Okay, and so the thing is that uh, when we didn't have any rover hardware rover available, so there is this software fake rover. Okay, and so the simplification was that this fake rover was used for all the rovers. Okay, and so what YaRG did is just to create different values for each rover, so that it works. So sorry, it's a detail. Okay, now we'd like to see why. Uh, we'd like to see that working, right? Um, so sorry. So when did you change the value?
In the morning,
But in the morning means when? Because
like 1 hour ago, 1 hour,
one
two
hour ago.
hours ago.
So okay, so not sure whether because we need to reload the configuration, and right now it requires restarting the
So
server.
should I reboot it?
You could reboot, but I'm restarting right now. Okay.
Okay.
Um, right. Okay. So it's restarted now, and if it works, great. Otherwise, there will be a bit more work.
Did you restart? Because my
Yes.
connection didn't close.
And so the server says that it cannot connect to your river because there is an SSL issue. So
Okay. But ngrok should solve that, right?
yes.
What is the SSL issue?
Um, sorry, just a quick check here. So the SSL issue, wrong version number.
Mm,
And so is it because of port 80? I don't know. Can you connect directly to the URL that you are?
yes. So if I post the URL I posted, then the URL ngrok gives. and I can move the rover.
Yes. Did we have that problem like last week as well?
Well, last week also the mini app to this ngrok would not the request would not come.
Sure, but this SSL error, it seems to me that we had that error last week as well.
But where do you see this?
That's what I'm trying to remember.
Okay.
You said you're not connecting to you are connecting to port 8080. Is that right?
Port 80.
Port 80. But
Hmm.
you're trying to connect to HTTPS over port 80?
Which is, yes, which is the question that
It-
I'm trying to solve because it works in the
because
browser, right?
generally HTTPS would be served over port 443.
Yes, yes,
Yeah,
yes.
yeah. Because I think that on file, env file,
Okay,
Eric,
okay.
in that
That's
it
actually,
specifies 80.
so sorry.
Uh,
It's thank you, but that's you're answering the question actually because in the configuration file we say port 80, but we say
yeah,
HTTPS at the same time. So that's why it doesn't work.
yeah, yeah.
Okay, so let me modify this right away. Um, would you mind to try again, Anuraj?
Yeah.
Mm,
No, it doesn't get the request.
okay. Um, is there anything we'd like to talk about as we are looking to this? Because
We can talk about discovery and registration, right? Like how would someone with a rover join once they have their firmware? It should be some sort of like script they could run, or do they register manually?
right.
Mm,
So would you mind to try it again? To try again because
yeah.
it's working, but apparently there is a problem getting pictures. Maybe.
Yeah, so there is no camera, so it won't work. The
Okay.
picture thing won't work.
So
Yeah.
you know the logic. What when I rewrote from version one frame v1 to the mini app, I didn't change the logic. Okay, so basically the assumption is that there is a camera with pictures. Okay, in the original code, if that doesn't happen, basically it crashes.
No. In the original code, it was basically like it would just uh, run and just give a warning that there was no camera. At least that is how I had done it. Well, it's not working anymore, but we can try.
But it's not working because there is no image available.
So it falls back to something else then.
The fake rover, yes, has a fallback. This is what I added. Okay, it's a separate thing. But the original code basically requires an image. So no image is not going to work. Okay. I can see that the request you're sending backward, stop, these
Yeah.
comments in the logs. Okay, maybe I can share the screen. It could be perhaps more interesting.
Yeah.
But just logs. Okay, and it crashes at getting the image basically.
Mm. I have the camera, but I don't know. I haven't tested it for a while.
Yeah.
Can't you spoof it? Like just send back a canned JPEG of some sort.
No,
Sorry.
it's requesting a image from an IP, right?
So sorry, there was a question to me. I did not understand. Sorry.
No, that was a question to Anuraj. If the code can be modified to just spoof the image.
No, it's
Okay.
basically it. So well, if you ask the camera ESP cam, then yeah, it should. But like it's I don't know if it how it integrates with the mini app.
I'm restarting the server so that the fake rover rover B becomes the fake rover. Okay, so that we can see. Okay. Oh, sure.
Did it start the server?
Yes. Okay, so interestingly, rover A is. So are we showing something? Sorry, because I'm just talking to my computer here. And,
Just talking to
not-
your computer.
Again. So this is what we have right now.
oh, you've been. Is it mine or yours? Yes, mine.
This is yours.
Okay, so here we have rover A and B. If I click to B, it should be apparently it's Aniraj rover. Okay. I know. That's wait a second. What? Okay. So the image we can see, and sorry, the format is strange. Okay, is the fake rover is basically just a software piece. Okay, that returns a fake image inside which we print the current time. Okay, and so it allows just to check that the application works fine end to end. Okay, assuming that we get images. And so here you see it's working when we have in this mode, the session lasts for 30 seconds. Okay, we can configure that. And when the session is finished, we come back to the main picture. But one of the two should have been Aniraj rover. So maybe I've made a mistake. I'm sorry.
Can we disable that camera request so that it moves forward?
Yes, yeah, I can do
Maybe
that.
maybe just comment it out so that it's not calling the
Mhm.
camera endpoints at all.
Yes. Okay.
Okay, it seems I got something. Uh, Okay, I'm getting it now.
But so there is one reason. Is because
Okay.
now understand your rover is rover A, okay,
Yeah.
and the fake rover is rover B, okay. The thing is that we have a common folder for all rovers with the images, and it seems there is a bug where basically if you have at least one image available in that folder, then this will work basically.
No, actually, I'm getting the request, but it's going to the wrong URL. Uh, so it's going to this slash tumblr slash a slash motor forward. So it shouldn't go there. It should just go to slash motor slash forward. So I'll share my screen. Uh, where did it go? So the requests are coming now, but it's going to the wrong endpoint. You see the terminal.
Yes.
So you see this slash tumblr slash a slash motor dot forward slash forward, the highlighted one, the first one.
Yep.
Maybe it's visible now. So the slash tumblr slash a should not be there. And then it will work. It should be something like this. Slash motor slash forward. Then it will work.
Sure.
Yeah. So yeah. So the requests are coming, only the endpoints are not working exactly. A small change might make it work.
So the thing that it's so I don't know after the modification this week, okay, but the thing that there is one URL per rover. So slash motor slash back doesn't tell what rover it is, right?
How was it? Like it you we have tested it with two rovers in frames v1. In the frames v1 logic, there was some splitting happening at some point. So it
Okay.
used to come and then it would basically, while forwarding it to the rover, it would remove those uh, identification and parts and then just forward it there. That one. So because in Bangkok, Venkat and I had been running the rovers with the same server, so it has worked. But yeah, I think we can maybe not debug it now.
Right, but it was working also when we did the port to mini app basically. Okay.
Yeah.
Now is quite a few changes have piled since the last time we used it. But anyway, yes, apparently there is a problem to look into. Okay.
So what were the changes you were suggesting? You had some plant changes, right?
But the no suggestion. It's more like to accommodate having more easily more rovers. Okay, so here we have two. Okay, the port when I ported to mini app, it was because the app was supporting only two rovers. Okay? So the idea is now to have dynamically a list of rovers available. Okay, and again for the moment we can just push the button of the one we want to select. And so the list of rovers available, we can put them in the configuration file for now. To be able to earlier today, we were talking about having perhaps a form to register dynamically a rover. That's something also relatively easy to add. Mhm.
I just made a small change to the environment file. I just removed that tumblr slash. Will that work in the rover base URL? if I restart the mini app.
Yeah. What did you change?
I just removed the environment file, the n slash tumblr slash a. I just removed that much part from the URL.
But if you restart, it should reload. Okay.
It, So I just reboot, right?
But what is going to be strange is that then there is no way to distinguish between rover A and rover B.
Yeah, that's fine. We can do that later. At least if we are able to test one, then it should be fine, right?
Sure. Well, at the
Is the
same time,
code on GitHub the like Tumblr FC mini app fast API repo? Is that it?
yes.
Yeah.
Okay, and it was updated like 3 hours ago, so that's relatively current.
So once again.
I was just saying, it looked like it was updated 3 hours ago, so it must be pretty current.
Oh yes, that's what we've done last week. But we could not merge. I didn't have the permissions to merge, so I did that today.
Cool. Yeah, I was just looking at how the environment variables were configuring the URLs for the different tumblers.
But that's legacy code from the very first version of this repository. Okay. It seems to me that it's not so interesting to look into that code. Okay. More into what's coming, okay, based on what we want, because there are a lot of duplications in the current code that can be removed to make it easier to read, for example. Okay.
Okay, let's try now. No, it doesn't work because the selection page doesn't work after that. So it will require some proper debugging to have the correct endpoints. Oh well. As
Live modification
they-
to live debugging leads to even more debugging, right?
yeah. But yeah, if you go to the ngrok URL, you should be able to control my rover. But then you have to copy paste the endpoints manually.
There is something. Yes, that this morning when I started to work on this, okay, this is where I noticed that the Webcaster, so the Farcaster requests, to authenticate, were not working anymore. Okay,
Yeah, at some
apparently,
point they had changed the naming or something. I don't know how much they are actually maintaining that, because a lot of the stuff now comes from like external hubs. So there's something called Nanar, and a lot of people just use the APIs from there. I don't know if Farcaster even serves. And like that the Python package we were using, yeah, that's I think not maintained anymore. It was mostly used for getting the FIDs and fnames
Mhm.
in the frames v1. We don't need to do that anymore. Yeah, so I think like this, we will need to rewrite it as a web app, and if we want to distribute on Farcaster, then basically we could convert it into a mini app, and the payment thing can be done via X402. I think Coinbase provides some SDKs for it. It should be not that difficult to.
But the thing that basically last time it was working, Confirm working, and we watched it together. I think it was in September. Okay, but right now we don't have any mini app at all until this is fixed, basically.
Yeah.
On our side. We don't have mini app. It just means that the protocol that we implemented, the mini app protocol, is apparently outdated and not accepted anymore now. Okay. So you remember we looked at the mini app control panel, okay, where the app was
Yep.
appearing or getting registered itself, with this the specific protocol, okay, and that apparently doesn't work anymore. Okay, it's outdated. That's the third time this year.
Yeah, if you look at what they're doing, becoming a wallet focused company, I think they're kind of giving up not just social, but also this mini app part of the business model. And the base app, I think, actually might be more, I don't know, support than Forecaster at this point. But I think basically what we've seen is Forecaster ecosystem is too fragile and unstable to build on top of. So we should kind of like build a MVP that doesn't rely on Forecaster, and then if it gets added, it should be like a robust failure layer, right?
Hmm.
Which is a little bit sad because it felt like free distribution, but I guess there's no free lunch.
So our server, okay, I'm not sure we can call it mini app, okay. If it can connect, it will connect. If it can't, it will just ignore, and then it's not a Farcaster mini app, and just runs as a plain web server. Okay? Um, so that's the situation today. So is there a sense of preference or priorities on getting back on such kind of network? Because it's there were some DevCon targets as well, right?
You are muted, Venkat.
I mean, the Forecaster as distribution was always kind of like a optional extra type of feature. If we just have a basic functional teleoperation interface for controlling multiple rovers, you can just tweet that, share that on any social medium with like just human distribution. That should be enough to make it popular. And if you want to like pursue the cryptobotics thread, then I think it's best to do that in almost a bare metal way. So that would mean like the web app itself should have a wallet login flow and do it directly. And I haven't looked at this 402 thing that Anuraj has looked at, but yeah, whatever we should try and rely on like the very basic protocols and not on a company like Farcaster or even Base. Like Base is more reliable because it's backed by Coinbase, so it's a bigger company with more funds, but it's still kind of an unreliable counterparty. So I would say if we can build on just plain Ethereum standards or base L2 standards, but not base the app. So I think relying on some L2 is fine, but not a particular app.
All right.
Yeah, so basically, like what Paycaster does, you could do it with Web3.py. What they do is basically give verify a transaction and send back a frame. That was what they were doing. So you could go below the stack and then implement it yourself. But like I think with X402, you work almost on. So they have something the same facilities as Paycaster, like but they have made it a protocol and an HTTP protocol, and they have like SDKs for it. So we don't have to completely rework.
So I think the one constraint that would then pop up is if you use like the basic protocols, it will end up being like just laptop browser type thing, because if you go by mobile, a DApp working through a mobile has that annoying wallet connect flow which fails like 90% of the time. Whereas I think the advantage that Forecaster offered
Yeah.
was integrated wallet and distribution network, so you didn't have to go back and forth with wallet connect and stuff. But still, if we just do web browser thing instead of mobile, which I think is actually fine, it's
Yeah, and the advantage with Miniapp was that you are already getting logged in wallet, right? So
yeah.
when you log into a Miniapp, you are already authenticated. So that was like a huge affordance there.
Yeah, and we can kind of like get something similar. Like one very trivial thing to do is just sell a token or NFT for like one USDC, and whoever wants to buy it can buy it, and that's their pass. They can use that, and if that NFT is present in their wallet, we can let them control the rover. I looked at that once. So basic token gating is a much simpler interaction than actually taking money from people. Like you can do basic token checking even without server side stuff. You can do it just in JavaScript. So yeah, so there's like simple ways to get identity. The hard part is getting money, but that's um, it's not critical to the robotics part. Like if we can think of an interesting reason why we take money at all, because the amount itself is not that significant. It's only interesting if there's like an interesting engineering use case for taking money, like running an internal economy of $1 gets you 10 commands kind of thing. But yeah, for now, I think we should just do a basic web app with a private URL. All of us can play with it and test it. When it's ready, we share it with other people with no payment and no authentication. But eventually, we start to add that back in some way.
Have you checked this Earth rover? Um,
Yes,
The one you
I
showed us.
looked at that recently. Didn't we see that in one of the recent?
yeah, so basically they also have like a web app where you can share your rover. So what we want to do,
Mm.
so you log in and then you get a test drive. So but it's all I think managed via some Discord thing. Yeah. So one way is like, how do we manage the registration? Like, what is the simplest way? Like, if somebody has a rover, how does the server know? Because
So
it has to,
Mhm.
because then you have to the web has to like forward the request right from the UI to the actual robot.
So the thing that we can have a plus button on the front page that leads to a simple form where we put a name of rover, the URL, okay, and that's about it actually. Okay, because if we don't have the Paycaster and mini app thing, that's about it. Okay, and the requirement is for that rover to use the library we've developed on YaRG, right, to expose. To be able to answer to the requests from our server.
Yeah.
So it can be a form, and we push a button, and we can have a local on the server. We can have a local database like a SQLite or something like that to maintain that. Basically.
Yeah,
Can
but
even do the CSV file.
there has to be a way for the server to know when the rover is offline, right? So there has to be some sort of heartbeat checks.
Sure, but
So
that's beyond registration, right?
Yeah.
Yes. If there is, if the library that you've developed, that you install on the rover, okay, if that library can have an extra endpoint for the heartbeat, yeah, we can do that. Can do that too.
And the other thing was how to know the IP. So right now, every time like you gets a new IP, you have to connect the serial port to actually check the IP. That is not very convenient. Yeah, so one way is to add the screen, or maybe use the Bluetooth to somehow know.
When we talked
Because
about this like 6 months ago, I recommended having the rover itself initiate the communication to like broadcast itself. Do you know what I mean?
How does that work on a LAN? Like the LAN is basically a bunch of like local Ethernet addresses, right? So would it broadcast some packets without any particular destination? How does broadcast work?
I don't mean at the IP level. I was thinking simpler, as in like it issues a HTTP request to central server to say I'm online.
Oh. The problem is, I think the rover only talks to the local laptop or whatever the home behind the firewall thing is. It doesn't.
Oh, it doesn't. It's not on the full network.
Yeah, that's what I think.
Not right now. If we use ngrok, then how would we do it? It can be done with the Tailscale solution, I think, because Tailscale everything gets a local IP, right?
But so how's the network work now?
So right now for the testing, we start an ngrok server and then we paste that ngrok variable inside the mini app server, inside that environment variable where it reads from. Not
Okay,
the
rover,
most elegant way, but
but the rover itself, it's like ESP32, right?
Yes, yeah.
It boots up what Wi-Fi? It's connected to the Wi-Fi?
To the local Wi-Fi, and then you manually start ngrok, right?
But
it
can't access the internet?
It can.
Oh.
But how will it know the server? How will it expose itself to outside world?
I'm saying that you bake into the ESP32 the URL of the frame server, whatever the central server is.
Okay. Yeah.
When it wakes up,
it
issues a request to say, "Hey, I'm alive," and then the server will know where it is.
Yeah, that can be done because it's basically the DigitalOcean server running at some IP and it's mapped to yakrover.com.
Okay, so we're trying to like engineer a duplex pathway here. So outbound, it can like tell somebody else its local IP, and then that central server has to tell from behind the firewall laptop that hey, your local IP, go talk to that guy and bring him on board. Is that the solution?
So basically, we could have a register endpoint on yakrover.com, which whenever a rover ESP32 comes online, it could ping that I'm online. But then, like, how would the server send the command back? Because it's not on it's behind a router, right?
And I don't like this solution just in general because it relies on phoning a remote central server to do something local. Like it should be engineered so that the local rover can find the local laptop and do stuff locally without ever breaking out of the LAN, right? That should be an optional extra go out to the world thing. Like what's the solution? Like suppose I made that like a hard constraint. You're not allowed to talk to the external world. You're going to stay behind the firewall, find the local laptop or other bigger computer and start talking to it and obeying its commands. How would you do that problem? Like another way would be if my laptop is online and I can discover the IP of my laptop, I could use the rover's camera to look at that, right? And then the rover can image process that, retrieve the laptop's local IP and maybe hook up to it. Is that a possibility? Like somebody has to know somebody else's IP locally, right?
I think the more elegant solution is to get rid of the laptop.
Yeah, but he wants to have the option of connecting with his laptop. What if we had the laptop also connecting to the remote server so they can find each other far, far away?
Let's assume internet is down. Can I still play with my rover at home? I should be.
Yes. As long as you know the IP.
Exactly. So, wait, actually, there's another dependency. The DHCP is being run by the local ISP. So if the internet is down, there is no way for the rover to even get assigned an IP, right? Unless you're
No, the router assigns. Your Wi-Fi router assigns.
Oh, okay.
That IP.
So the LAN can be alive even if outside the home is not going. Okay. So this seems like it should be solvable. The rover knows its IP. The laptop or whatever other command interface you're using knows its IP. Everything is local. Why can't we connect the two?
No, because the yakrover.com doesn't know the ngrok IP. That is how we are
No,
exposing.
I'm saying forget YaRG Rover or ngrok or anything like that. Like just completely locally. My laptop can scan and discover the printer and say, here are available printers, pick one, print to it. Why some sort of like local network scanning way to discover local
So
robots?
you will, if you do ARP scans on your network, you will see the IP, but it won't know if it's a ESP32.
The MAC
It will.
address
So
is stable though, right? So
Well,
if
yeah,
you can search for ports, open ports and whatnot, using nmat.
and the MAC address is stable for any device, right? So you could
yeah.
look at the binding and say, hey, I know the rover's MAC address, so I will
So
treat.
the thing that now you have MAC address randomization for many devices.
Okay.
But not for
Yes.
ESP32, I think.
Maybe not for embedded, but if you take any smartphone now,
Yeah.
the MAC is randomized. So
Hmm.
it's difficult to rely on that. Okay, but here again we are talking about the discovery protocol, right? Because you see for the printer, I think it's a great example, Venkat, because I don't remember which. Is it the CUPS protocol that is used for printers?
I don't know what's
Yeah, something like that. Yes.
Yes. And so the thing that is there a protocol for IoT, because what was the one that we talked about recently and YaRG twice, including last week? The one is the recent protocol, which is for discovery, but nothing prevents it, I think, to be available right on a local network without internet access, right? Otherwise, there are things like MDNS, okay, where you can access on your local network another device by putting the device name, the host name, and putting .local at the end. Okay? So if I have a computer called ABC on my local network, I can connect to it without knowing the IP address with abc.local. So it's assuming that all the machines know the MDNS protocol, but most of them do now. Okay.
Is there something simpler, like going back to what Rhett was suggesting? If this, I don't know what this ARP thing is, but assuming it gives you a list of like local IP addresses with MAC addresses that may or may not be randomized, at least you have a set of local IPs. And for a small home network, chances are there's not going to be more than 20 devices on it. Like if it's a huge network, there might be thousands, but 20 is reasonable. You can just go ask each of it according to some pre-agreed convention of, like, ping this port and say, are you a rover? And if it answers yes, I'm a rover, you've got a hit. At most you have to ask 20 times and one of them is going to turn out to be the rover, right?
Mhm.
Is this extremely dumb thing doable?
Yeah, that is possible.
I mean, it's so doable. You could even implement the printer protocol on the ESP32 and use that broadcast to get just a list of printers and rovers on your network.
That would be nice.
Mhm.
Yeah, I think that's worth doing, because it feels like this is actually kind of subsumption architecture, but for device discovery, right? Like, Eric, you like subsumption architecture, and one of the principles is the lowest level supersedes the next higher level and next higher level and so forth, right? So it's very graceful degradation. The top 5 levels fail, the bottom 4 levels will still have like a dumber device, right? So in this case, it's like it's going to be looking for some local command computer to give it commands. And if that works, then it'll try the next step of like phoning yakrover.com. If that works, it'll try to start the mini app server and talk to people on Farcaster. So this seems like the natural way to proceed, right? And again, with as dumb protocol as possible. So I like the idea of like printers and robots being part of the same discovery protocol.
I also like the generality of Red's idea, although it's a bit brute force. But I like how Venkatesh you jump from we should have 20 IPs used at home. I think we have even more than that now, honestly. Okay?
I looked recently. I think I had like 15 or it was less than 20. We don't have too many Wi-Fi connected devices in our home. It's more than I thought, but not as many as I feared. I didn't have 200 devices sitting around.
It's when you can't figure out what that last one is. Like, I can only count 19. What's the number 20?
So the thing is that usually on the LAN, you have a maximum of like 255 or addresses, right? Actually, less than that. Okay, and so it's a bit brute force, but it's not so expensive. What would be fun is that we have our mini protocol where the server that runs on the rover. Okay, so Anuaj, what you wrote, to have an endpoint that is called I am a rover. Okay, and we just scan all the IPs on that segment, so 250 address, and we just find all the ones that answer to that call. There is a problem of port though, okay, but we can also document that the rovers must have a port ranging from that address to that address. Okay, but we have to be careful because people in security will criticize that very much.
But then, how will the web app know? Then it assumes that you are on the same network, so it has to be some sort of tail-scale solution or VPN solution.
So I think the web app always discovers new rovers through somebody else's local network. So first you join YaRG rover team as like a person and say, hey, I would like to join your team. And then you declare, I don't know, your laptop or some other like trusted device as like a source of new rover referrals. And after that, you get to like nominate rovers to the web server level, right? Like right now, all of us have 1 or 2 rovers, and we might add more. This should be the natural way. Like I should discover it like a printer, hit a button, commit it to GitHub as like, I don't know, some sort of like YAML or other config file that then gets committed to the web server. And since I'm a trusted party, I have added to the directory.
So can we just copy the mechanism of network printer mapping? In other words, there's some way that you can make your printer available on the internet. Anybody who wants to use it, and we just copy that.
Well, you don't need to go to the printer level. So you can use the MQTT discovery protocol. It's an IoT discovery protocol you just published. You can the printer protocol might be a little more complex than the IoT protocol, so we could use any one.
I'm just saying, take an existing protocol that works. And
so MQTT is also used in Home Assistant networks.
That makes sense.
Yeah, that's good. And I think we can keep it general. I think the only constraint we have is right now we are going to be using ESP32 as our standard chip. So it should be like, hey, I'm an ESP32 powered device. I'm a robot. It can even be natural language because eventually we'll be putting like, AI powered middleware. So we shouldn't like even go down the road of defining precise vocabularies for like declaring what you can do. It should just be like, hey, I'm a new artistic prototype robot that uses ESP32s, but I have 15 legs and I don't know, a Nerf gun or something. So it should be able to declare completely arbitrary capabilities. And the right way to do this, I think, is natural language self-descriptions that then get integrated into like VLA type command architecture. So some of the Twitter stuff I was posting in the thread, it looks like VLA, so that's vision language action models. They're like really exploding in the last month, and that's basically a full natural language stack. So we really should future-proof by doing that instead of like defining a very precise vocabulary for what a robot is or what it can do.
One of the advantages of having a predefined protocol is that it doesn't get co-opted. If you use natural language, we could have like what you have in dating apps, which have their own language, and you can't believe anything anybody says, and so on.
I kind of like that. Like, imagine the big success case, and this project has like 1 million rovers all over the world. I mean, people are unreliable, so they're going to build rovers that are unreliable. Some will be like threat actors, some will be like fun art projects, some will be really robust, some will like fail half the time. So you kind of want to prepare for a messy world, I think. Like some will misrepresent, right? Like somebody might say, hey, I really want to be part of this community, so I'm going to pretend I have a really powerful rover with like, 6 motors and like 5 cameras, but it's pretending and it's faking it all. And
let me ask this question. Can we copy some open source dating architecture?
Is there such a thing? I thought all dating apps were vertical proprietary thing. There might be.
I'm sure that exists.
Couchsurfing was that for not dating, but it was like before Airbnb. There was this thing called couchsurfing, which was people would just offer their couches for free. But there
Okay.
was a centralized team. Yeah.
I'm gonna put a link. There's definitely an open source dating software. And you can also put in plugins.
But right
And
now, I think the bottom
nobody
layer is
bother about himself, you know.
Let me see if I can try to implement this MQTT discovery protocol on the rover. So, but then we'll still need a local computer or RPI as well.
and I think that you will need until we add the big brain RPI to the rover, right? At that point, we can like do without the local one, but you still need, I think, some way for people to locally command and control the rover, unless it's fully autonomous. Like you shouldn't always have to go to the web app. If I just want to make a rover that does household chores, and I don't want to expose it to the world, I should still have a way to command it, right?
Why do you feel that way? Why do you feel that you have to have local control and it can't always go through a remote location?
Partly to make it resistant to internet outages is one big one. Another is there's just a lot of like good robotic application ideas that you would want to just keep private, right? You don't want to expose it to the world at all.
I don't know what you mean by exposed.
I would say if the discovery and command and control loop goes through DigitalOcean server, that's way outside my security perimeter. I would say the local router should establish the security perimeter, and there should be like a meaningful activity there. And the default should be it stays in unless it's let out, not the default being it's outside unless you do something to keep it in.
Mm-hmm.
It's also two levels of decentralization, right?
Yeah.
I mean, if we depend, right now we depend on the yakrover.com domain. So we depend on the internet. While if the rover is just next to the computer on the same network, let's say an ideal decentralization would say, okay, it's there, so why can't I connect, basically, if internet is down?
So
again,
ESP32 by default provides this MDNS as a component.
Mm-hmm.
So I think like that is the.
But MDNS is also dependent on your local network infrastructure, right, to support.
Yes.
But that's at minimum and necessary, right? How else you need a router doing at least local housekeeping?
No, I mean like the router may or may not actually support that. Like I think it's a thing you have to have turned on or not. I think.
I think now
maybe it's universally on. I don't know, but
the MDNS, if I remember well, is purely software, right? I mean, it's two machines can connect over any kind of network, assuming they have the MDNS implementation. Okay, it's a protocol that they do transparently, basically.
Okay.
Yes. So it should work even if the router doesn't support it. I mean, I'm not completely sure, but I don't think there is anything to support at the router level, basically. Okay? It's really inside the operating system, whether the library is available or not. Okay? However, we still need to know, for example, the name of the ESP32. Okay, or it should be configured, but it's not like it will automatically discover it, basically. Okay, we still need to have a name, right? Okay. But I like what you shared, Rhett, on the MQTT protocol because MQTT, so it's a protocol that is typically used for IoT devices and so on. And I wonder whether there is a discovery service or something that facilitates discovery. But the link that you shared, Rhett, has something interesting that there is MQTT over TCP, okay? And what's interesting is that they are default ports, okay? So that can simplify discovery because we know that on our local network there is a bunch of IP addresses. Okay, but we can make the requirement that any rover that wants to join this this app, okay, need to have, for example, the default MQTT protocol enabled. Then we can do the discovery because we know the port is the default one. Okay? Adopting such kind of standard could help could simplify the problem. Okay? It's not full discovery though.
Let me ask a question that might actually generalize the pattern even better. I already have 2 full rovers and I have like a partial third one and the 4th Galaxy rover. So my house already has like 4 half-complete rovers. Ideally, even my laptop shouldn't be necessary for like local fun, right? If all 4 rovers are turned on and have been assigned IP addresses and have cameras pointing at each other, if one rover sees another, like if it's humans, I could just walk up and say, "Hey, I'm Venkat. Nice to meet you." We shake hands and we start talking, right? It's awkward, but it's doable. Humans do this. So if you have 2 rovers running around and they see each other in each other's cameras, is there some like quick way for one rover to realize that, hey, there's another entity here that I could probably do some interesting coordination with? Let me try to find them on the network, then connect, and then you can do like, swarming and formations and things like that. So here's a bootstrap way to do that. Visually on each rover, you put a little sticker with a number or something. I don't know, it's MAC address or some other stable identifier. Use the camera to identify and then look for it on the network, connect, and then you do like local peering. It's like a bootstrapped local ad hoc network.
So what you're saying is it's like a name tag with a name.
Yeah.
My name is Q53 and you see it.
Yeah.
And you talk through the network.
Yes. And so long as you have some stable mapping between what you display on your name badge and like a hard-coded global variable in your ESP's firmware or wherever, you should be able to connect the dots, right? Like even if you have like randomized MAC addresses or whatever else is going on, I know that my name badge says Venkat, and if somebody in audio says Venkat, I can connect the dots that the audio phoneme connects to my visual thing, right? That's effectively the same process going on. It doesn't rely on what type of hat I'm wearing in a particular day.
I was just reading about MDNS, and it does actually sound like it would work pretty well for this sort of thing as long as you're on the same subnet.
Yes.
It is all of it's doing is broadcasting out a packet on port 5353, and whoever answers. So you just we'd have to add to the ESP32 a MDNS implementation, and then it could answer.
If I remember well, MDNS is based on an older protocol from Apple called Bonjour. Okay.
And so that longer uses it.
Yeah, and so I think when Apple was still doing printers, okay, it was in the 90s, right, or something like that. Okay. They had that protocol to be able to discover on the local network automatically. Okay. But still, I wonder whether there is not something about knowing the name. No? And it's not like it's a really automatic discovery.
Yeah, you still have to have the name, I think.
Well, devices can declare their name if asked, right? Like you don't have to know my name. You can ask me. So what happens, you scan through the ARP list, you have a bunch of static IPs. You query each of them, and no answer means it doesn't understand the language you're asking its name in. If it answers to a name, then you can I'm not sure why this is a roadblock.
Yeah, that is like one way to do it. Yes. You just maybe in one subnet, what you have like 256 devices.
Yeah, that's like a minute in a for loop, right? At most, like it either very quickly answers or it doesn't. And I think I like the idea of local Wi-Fi better than things like Bluetooth or NFC that rely too much on like actual physical proximity, because it's just more flexible.
And some of us obviously have homes that are big enough that you can't get Bluetooth from one edge to the other.
Yeah, I think this is an interesting problem because then something like a laptop local host web server for controlling things just becomes another instance of a node in the network. It just happens to be a very dumb rover that can't move or do anything. All it can do is like give orders to other rovers. Right? So we can actually make this completely symmetric. So maybe the laptop should also run whatever the rover runs, and it becomes like a symmetric discovery process. The laptop just happens to have some additional features like it has a screen and a keyboard. It can pop up a web page with like forward, backward, turn type commands, and it can bootstrap other devices onto the global internet.
It's a very interesting problem, but it's something that has been a kind of a target for decades. Okay, and it seems I'm not so sure, but it seems to me that the problem is always security at some point.
Yes.
Okay, so
I think the reason it hasn't been solved is the people who are trying to solve it are trying to solve much bigger problems with harder constraints, right? If Apple is trying to solve this problem, it's trying to solve it for like the entire planet with like assurable security. We are just trying to solve it for a single local network, at least initially.
Oh,
yeah, but transparently solve it, because we also want that. Okay, if YaRGWeather.com is accessible, to be able to use that as well, right?
Yes.
Smoothly. Okay.
Yeah.
So then we need extra logic to switch between. Okay, I'm trying to connect to a local rover available here. So then I do a direct link, and a mode where okay, we are trying to connect to a rover that is available but is not local. And so go through YaRGWeather.com basically, right?
Yes. And that's where other things like Tailscale and stuff comes up. And there I think devices can be as risk-taking as their capabilities allow, right? So if you are running a rover with an RPi that's actually connected to the internet, it can try to do more ambitious things.
For Tailscale, can it run directly on the ESP or
No. They have bindings for it, but I don't know if somebody else. So they have like a Go library, but I think like page.
It looked very difficult.
Yeah,
Mhm.
but I think you can run page kite on ESP32.
Yeah.
Because so they have an embedded library specifically for small devices.
But can those libraries work on the LAN?
What do you
I mean,
mean on LAN?
for example, a Tailscale or a kite network on a LAN. It doesn't really make sense, okay? But this is perhaps the question: is that is to have this smoothness that if we can't get the internet, it's still working.
I don't know about this. Tailscale is just a VPN, right? So it should, if somebody is porting, it's based on WireGuard, I think, and people have ported WireGuard to ESP32. So it should be possible on LAN. Tailscale is just extra features on top of WireGuard. So if you want to use those extra features, then you use Tailscale. But then if you use Tailscale, then like each of our rovers are on the same network.
So
Yeah, it's the extra features that are what solves the problem. What we're talking about.
Yeah.
WireGuard just doesn't solve the service discovery problem.
And so, if those features depend on the internet, then it doesn't address the problem either, right?
Right.
yeah. So I think there's a future speculation question here. Do we believe that as these low-level, cheapest scale embedded processors like ESP class with like low power and stuff, will they ever become powerful enough to basically be independent devices on the internet, or will they always go through like slightly more powerful devices to go to the internet? Like, can they run extremely stripped down Linux and TCP/IP stack and the tail scale?
So it has a TCP/IP stack. It's called like, yeah. So embed T there is embed TLS which you could basically use it, but then it's a lot of work, right?
But I'm asking a future-oriented question. Like 10 years from now, if you extrapolate the trajectory of ESP32 class devices, do you see them becoming powerful enough, or do you see them
So
actually going the other direction where people lower the power and cost so much that
like
they remain?
I mean, you could simply just add more compute.
yeah. So basically, like, what do you? So there is only already 1 gigahertz microcontroller from NXP32 or STM32, right? Like there are like class of devices which are almost as powerful as like small desktop, but they call it microcontrollers because of the features. So yeah, it's possible to basically run the entire IP stack on it.
Yeah.
Um, so it depends on the application, right? Like right now the kind of processor we have, it will be compute intensive for it, but in the same package you could get a powerful compute unit that could
Oh,
do all the IP things.
okay. I get what you're saying. I think I'm asking a different question. Um, I think what I'm asking is, in the future, do you see these extremely low-end devices just going away and everything becomes at least minimum viable internet capable? Or do you see a future where the
Yeah.
lowest end actually gets lower and lower towards the, the gray goo science fiction scenario where the smallest processors are like nanoparticles of dust and they can only connect locally to the next particle of dust 5 millimeters away, right? So those are two very different futures. If you see
I think
gray,
we'll have both.
okay. So
Yeah,
if you have
because
both, I think it's worth. So the reason I'm asking this as a diagnostic question is, if there is an interesting future where the extremely low power, low end stuff remains a big part of the ecosystem, it's worth designing like protocols and technology to support them, right? Because then you can imagine things like, all right, you can have more powerful rovers, but you can also have extremely tiny rovers like insect-sized rovers and stuff. So if you want to support that future, then you create, these local low power discovery protocols.
I,
Like
I,
if you had gray goo, like if you had gray goo today, how would particles of gray goo discover each other, right? That's a good asymptotic thought experiment to do.
I I think it's a matter of, let's call it protocol creep. As the processors become more powerful, then we want to make them more protected against attack. And then they need that more power. So right now, I could connect to the internet with a ESP32, but at some point, we don't want to have 10 billion ESP32s being used for denial of service attack. So it becomes accepted that you have to have a firewall built in and maybe some AI cyber protection and so on, which is not a problem because 5 years from now, the ESP32 that we have is, 30 times more powerful with 10 times more memory. So I don't think the question is can we? Okay, I think the question is will we? And I think the
Yeah.
more capability we have, the more we'll want to use it for things like safety and.
Yeah, and I think I agree with Anuraj that both ends of the spectrum are going to come into existence. Both the extremely low power, low capability stuff will keep pushing the bottom and the top, right? So the range of devices will increase. Actually, that's always been historically true, right? The first computers were just one big mainframe. Now the range goes from microcontrollers to, cloud data centers. The future range would be gray goo to orbital data centers running on satellites, right? So I think the reason all this is interesting to me is I think um, just the home environment alone is like a very interesting, like even if you don't go to the internet at all, imagine like 10 years from now the home might be like uh, uh, 10,000 tiny devices all on like some really complex thing that looks like an internet inside your house, and most of it should stay there. You are not going to like connect it to the rest of the world.
Well, we already talked about the fact that my vacuum cleaner doesn't like my toy, whatever, because they're fighting. So it'll definitely have a feature that can suppress other robots that don't interfere with its work. And there's the arm race starts.
But yeah, I think this problem is worth solving. Like, just how do you discover how do you start talking to the rover that you can see right in front of you with the device that you can, as a human, interact with? So I think that's a worthwhile problem to solve right now.
What about IPv6? I know you really use them, so I'm not sure, but now most devices are IPv6 ready, right? If I'm not mistaken, it's a unique address, right?
Yep.
I did a project in college on mobile IPv6 networks. This was the dream that in the future, everyone would have like a computer they carry around with them connected to some worldwide network. And you obviously would want to be able to receive your email on it. So you need an IP address that was constant on your device that you were carrying with you. And as you traveled the world, you negotiate with all the routers to get your IP address routed correctly across the earth. It was a dream that didn't quite happen. But there's a protocol for it, and there's software that you can run if you really wanted to.
Yeah. I'm not sure where V6 is going, but that sounds scary. That okay, we know where you are.
Well, how are you going to send me an email if you don't know where my computer is?
Okay, we have 15 minutes past.
Yeah.
Yeah, getting pretty late.
All right. Are we meeting next week? It's Christmas Eve.
Maybe not.
Not for me.
Christmas Day.
So let's drop next week. The week after, I'm happy to join if everybody's up for it. That would be January 2nd? No, 1st. December 21st, I think.
Yeah.
Whatever. It's the time to be drunk.
All right. So maybe we skip the next 2 weeks. That's going to be December 31st. So
yeah.
The next call should be then January 7th.
Yes, 7th, 8th.
Yeah, 7th, 8th.
Yep. All right. Sounds good.
All right.
Enjoy your time for the next, for the end of this year. And see you on the other side. Huh?
Yeah.
Yep. Merry Christmas. Happy New Year.
Bye.
Nice.
Thank you.